So it's a pretty simple question. What happens when the amount of sediment exceeds the river's capacity to carry it? So pause it, think about that. And the answer is deposition. So essentially the weathered sediment is finally laid down. Some duh statements here, but if a river flow is fast, more particles are picked up than dropped. And if a river flow is slow, more particles are dropped than picked up. So one of the characteristics we're going to see here is where we're going to get areas of more deposition, like I said before, where we get flatter slopes. We're going to get a more meandering river. Meandering, as we'll see here in the following slide when we look at the Amazon. So meandering streams are going to be more characteristic of deposition, whereas those whitewater rapids, those mountainous areas with that fast flow of water are going to be more eroders, carving out a lot of that sediment that is eventually carried and deposited and transported at the bottom when it starts to more of a gentle flow. And so here's the meandering Amazon River. And so this is very much one of the things we think of whenever we see a flat area, a river coming through there. We're going to get very much a meandering river, which I hope you can visualize here in this image. Now let's take a look at some stream landforms, beginning with the Alluvial Plain. And so Alluvial Plain, large, massive. And so Alluvial Plain is a large, flat area of dropped, fine-grained, small alluvium. What is alluvium? Alluvium is deposited clay, silt, and sand from highland areas. And so alluvial plains were very much, as it characterized, very flat, but also lowland areas. Alluvial plains, typically they're going to be very large in size. So, although there might be an alluvial plain here along the White River, alluvial plains we're going to think of as being much larger in size. So we'll differentiate this from a floodplain here in a minute. And so take a look at the Google Maps of the Amazon River and the Mississippi alluvial plain. So Google those and take a look and see what you find. Here's our good friend the Hoang He River, also known as the Yellow River. So it's the most sediment-filled river on Earth, and so it's loaded with alluvium. And so what we've got going on is, as it carries that alluvium, its sediment from areas further inland, it eventually flows into I believe the Boha Sea. Anyway, so essentially what we can see is the alluvium being carried and deposited in this image. Here's 1995. I mean, we can very much see that here. But one of the concerns is this river, especially in flat lowland areas, it typically changes its course. So it typically changes its, kind of back and forth, its origin and its destination, which we can see here in some following images. So now we've got the flow coming out the one side, and now it's coming out of the north side, coming out of a completely different direction. So one of the characteristics of a lowland alluvium area is it's very natural for it to change its course, and so it can be problematic if you're living here for sure. When all of a sudden on one side the river is flowing, and then all of a sudden after a major rain event or maybe a hurricane comes through here, it flows a different direction. More of the same. Next up is floodplains. So every single river has a floodplain, and so these floodplains are filled with layers of alluvium. And key to this is the idea of we get this kind of this slope, the gradual gradient starts to decline, less and less, and so it becomes more flat, and it forms that meandering stream. So often it occurs after the stream is kind of down-cutted. As it stops down-cutting, as it stops that flow, it becomes much less. It becomes more, like I said before, of a depositor than an eroder. So one of the things is we get kind of this area around a stream which tends to be quite flat, but once again it's a floodplain, so it floods often. So as that flooding occurs, what it does is then the flow of water brings that sediment to a greater amount of area, of course then drops that sediment as that floodplain, as the rain event declines, and the flow all of a sudden goes back to its original amount of discharge. And so what happens is the sediment along the sides of a river is then laid down, leaving those layers of alluvium. So once again, low-lying flat areas, but much smaller than alluvial plains. Of course, alluvial plains we can see from space. We can see the Mississippi alluvial plain. If you Wikipedia it and you Google it, you'll see it's a massive area. So it's kind of like a floodplain to the 12th degree. Where floodplains, like I said, every single river has one. So even here, the White River, we are currently IUPUI. We are in the White River floodplain, the White River West Fork floodplain. So if we look below Kavanaugh Hall, below the lecture hall, we'll find these layers of alluvium, this fine-grained sediment, created from a time when this area flooded quite often. Of course, Indianapolis and IUPUI, we don't want this area to flood, and so we've protected ourselves and we've created these these man-made features to prevent this area from flooding, of course, because of the devastation that would cause. Characteristics we also find within the stream landform, and so one of the things that probably a lot of you have already clicked the next slide because you don't want to hear me ramble, but you're missing out, if you did, on the two next topics, which are very much critical to understanding what we would expect to see if we flew over most of the rivers in Indiana. What you'd expect to see is on one side, on the outer side of the meander, what we call a cut bank or an undercut bank. So that's going to be found at the outer portion of the meandering curve. And so once again, we talked about this beforehand. The fastest flow of a river is always over the deepest channel, and so it essentially carves out a deeper and deeper channel. So we can find the cut bank typically going to be on the outer side and have much more erosive capabilities than the other side, the inside of the meander, which we call the point bar. So the point bar deposit is going to be the inner portion of the meander. So here we're going to have the slower water velocity on the inside. So where sediment collects. And so we're going to see undercut bank is more an eroder, where point bar deposits are where we're going to see more deposition. So the undercut bank, point bar, get these stuck in the head as we look at some specific examples in the following slides. Here we have a meandering river, and so the red line illustrates where the velocity is the fastest as this river flows from the north to the south. And so some characteristics we would find is on the outer meander, we would find faster velocity, and then also a more cut bank, a steep slope, where on the inside we see more of that point bar deposit, kind of that U-shape, horseshoe shape. And so these are kind of the very much the characteristics we would expect. Now, one way to illustrate, okay, well, why is it faster on the outside? If you can think about a major sporting event, think about the Colts games. You've got 70,000 people all leaving at once, and so when people all leave at once, they go down the stairs. If you go down the stairs, coming from, let's say, the top, the cheap seats down to the bottom, to the exit level, one of the things is you notice is if you walk on the inside or up against the railing down the stairwell, you'll notice it's not as fast as when you walk on the outside. You're essentially going the same distance as everyone else, but you're not going as fast. It's a tighter corner. Whereas on the outer part, walking down the stairs, massive, 70,000 people leaving, it's freer, so you can move at a faster pace, although you're going the same distance, because obviously you're still going the same, down the same steps. And so the outer part of that we can relate to this river here, this image here, regarding the outer portion of that meander is where we're going to find faster flow. So go to a sporting event, walk down the stairs with 70,000 people, and then visualize this and kind of compare it to the flow of this river. And so, like I said, we can actually see this here in the Midwest. And so here is the Mississippi River, I believe, or whatever river it is. But we can see the point bar deposits on the inside of the meander and a much steeper cut bank found on the outer side of the meander. And so you can see where that sediment has collected, creating these little point bars, these little areas. They're almost like mini beaches on the inside of a meander. And you can see them all the way down from the top to the bottom. So carrying on with types of landforms that we expect to see in a floodplain, beginning with an Oxbow Lake. In an Oxbow Lake, thinking back once again, these are flat areas, typically, which they have these meandering streams. And these meandering streams, as I showcased on the previous slide, They change their course over time. And so what we can find is in certain areas we get what we call a cutoff from that meandering stream, creating the situation where you get a Oxbow Lake, or this lake that's essentially where the river used to be. Of course, there's still water that's collected, creating this lake. These are also referred to as billabongs in Australia, for those interested in Australian Oxbow Lake terminology. And meander scars, essentially what ends up happening is this Oxbow Lake has separated. We'll get plenty of images to show this in a following slide to give you more of an kind of understanding. But what happens is that Oxbow Lake is a cutoff, and so no longer does it have anything that's feeding it. No longer does it, it's not a part of the river, and so where is it getting that water from? Well, it only gets it from precipitation from rain. And so for the most part, all Oxbow Lakes eventually dry up. And when they dry up, they leave what we call a meander scar. This area that used to be an Oxbow Lake. And so a meander scar is essentially an Oxbow Lake that's dried up scar. Following is an animation that pretty much showcases what we just saw there in that video. So we get a major rain event, and so the stream might get a cutoff, meander might change. And so over time, deposition starts to build up along the sides, creating a situation where this cutoff of this meander becomes an oxbow. And so that deposition creates a situation where an Oxbow Lake is formed. And eventually a meander scar. And so one of the things, we see these all the time. And so in flat areas, Pakistan, India has a good amount of these flat areas, Bangladesh, flat areas that have these meandering rivers and a ton of Oxbow Lakes. And these are often caused by major rain events. So you get the monsoon season, creates a lot of Oxbow Lakes, creates a lot of cut-off meanders from those massive rain events that typically happen during that wet season, that wet monsoon season. And here's more of the same from the same area. This is just one rain event completely changed the meander and then created this Oxbow Lake in Pakistan. First off, let's figure out where we are. We're on the border between Iowa and Nebraska. And so Iowa and Nebraska separated by the Missouri River. And so the Missouri River separates these two states. It's a natural boundary between the two. And so what we have is Iowa in green, Nebraska in yellow. And so when you fly into Omaha, Nebraska, you fly into Epley Airfield here. And so here I am, a professional geographer, flew into Epley Airfield, and of course, okay, I'm in Nebraska, cool. And so as I got on the chartered bus taking us to Lincoln, Nebraska, and that's what's showcased here in this red line, we were cruising along, and all of a sudden, a sign said, "Welcome to Iowa." And so as we follow along this red line, all of a sudden, boom, the sign said, "Hey, welcome to Iowa." And here I was, professional geographer, and immediately, what do? I look underneath me. Well, where's the Missouri River? If I should be in Iowa, I should have crossed the Missouri River. Go through a stoplight or two, get to the other side, and a sign says, "Welcome to Nebraska." So this is toward the end of that arrow. So I'm thinking, well, where in the hell is the Missouri River? I should have gone over it twice. Well, what happened here was, when the states were first designed, when the states were, declared or whatever, the Missouri River followed the shape of what created Carter Lake. And so essentially the Missouri River has changed its course since becoming the natural boundary, being used as the natural state line between Nebraska and Iowa. And so what happened since then is that cut off of that meander. And so because they don't want to change the rules, and if you live in Carter Lake, Iowa, and you're proud to be Iowa, you're cool with that, you don't want to be Nebraskan, then you're not going to change. And so this area we see here created from an Oxbow Lake. Kind of this perplexing deal that even stumped the most professional of professional geographers.